Let's talk about this question. We are given the graph of the first derivative, and we'd like to answer on what interval is the original function increasing, decreasing. Unfortunately, we're not given the graph of the original function, so we cannot just say for the increasing part, it's a part that's been go up, and for decreasing, it's the part that's been going down. It's not like that. We have to make the connection between the first derivative and how can we tell the original function is being increasing. And the connection is, if the original is increasing, that means the first derivative has to be positive. And likewise, if the original is decreasing, that means the first derivative has to be negative. When you are given a graph, we have to look at the values. In that case, what we do is we just look at what's above the x-axis and what's below the x-axis. Anything that's above the x-axis, it's positive value, and anything below the x-axis, it's a negative value. Okay? So I'm looking for the f it's been increasing. That means I want the first derivative to be positive. That means I'm looking for the part that's above the x-axis, which is going to be this part, right? And from this part, like that. So the blue part I draw right here, let me just make it more blue right here for you guys. Okay, so we can answer the question. The first blue part is going to be from 0 to 1. And we don't include endpoints, so we just put 0 to 1. And union, the second part will be, this is 3 to 5. 3, 5. And that's it for the original function to be increasing. And for the original function to be decreasing, we look at the graph of the derivative to see where is it below the x-axis. Namely, it's going to be here and here, below the x-axis, to get negative values for that. In other words, from 1 to 3, union, the second part will be from 5 to 6. And that's it. Next question is that at what x values does the original function has a local maximum, has a local minimum? Let's talk about how can we get the local maximum. So for the local maximum, let me just kind of box this right here. This part is where f prime, where the first derivative changes from, well, you have to make sure it's go up and then go down, right? So it changes from positive to negative. So let's see, where is the graph changes from positive to negative, from blue to red? As you can see, we have one point right here and another point right here. You look at the graph from left to right. At 1, before 1 you get blue, after 1 you get red. So it changes from positive to negative. So we know x value equal to 1. Similarly, for number 5, x value equal to 5, it changes from positive to negative, right? Above the x-axis and below x-axis. So this right here will also give you a local maximum for the original. So x is equal to 1, x is equal to 5. How about local minimum? For local minimum, it's just going to be changes from negative to positive, because the function has to go down and then go up. So for the local minimum, will be right here because it's negative derivative, right? Below x-axis, and then above x-axis, and that's the only point that we have, which is x is equal to 3. And this is it. And once again, do not get confused on what kind of graph we are given. This is the graph of the derivative. So we have to remember these little details so we can talk about the original functions. And this is it.